In this tutorial, we will be discussing the dissociation of water. Additionally, how to calculate the concentration of the hydrogen, the H3O plus ion, and the hydroxide ion. Water is amphoteric, which means it can be both an acid or a base. If we look at both of these compounds here, they're identical. They're water. This hydrogen here is highlighted in red because these electrons of the oxygen is going to come over and it's going to take away that hydrogen. So if you see here, now he has 3 hydrogens and a plus sign, whereas this one only has 1 hydrogen and now has a negative sign. This happens all the time in water and in any other solution that you have. As a result, this is acting as both an acid and a base, which is the very definition of amphoteric. So when we start looking at how often this happens, it's actually a very small amount, but because it's constant, we're able to compare it in different solutions and by adding different chemicals. In pure water, this is happening 1 times 10 to the negative 7 times. And so we use something called the ion product in order to figure out how one affects the other. So here 1 times 10 to the negative 7, 1 times 10 to the negative 7, because this is pure, is going to equal 1 times 10 to the negative 14. And we're going to use this number when we're determining the concentration of either one of those chemicals. The ion product constant for water is defined as the product of the concentrations of H3O plus, and you're going to see a box around those because that's the abbreviation for concentration, and OH minus, and is always equal to 1 times 10 to the negative 14th at 25 degrees Celsius. When H3O and OH minus are equal, the concentrations are neutral. The acidity is neutral. If we have more H3O plus, it's considered acidic. If we have more OH minus, it's considered basic. If we know the concentration of either one of these, we can actually calculate the one that we don't know. So if we know H3O plus, because this is constant, this will always be 1.0 times 10 to the negative 14. If we know one of these, we can figure out the other one. So at neutral, the concentrations are the same. They're both 1 times 10 to the negative 7. But if it's an acid, we're going to have more of the H3O plus, and the OH minus is going to go down. If it's a base, we'll have more of the OH minus, and the H3O plus is going to go down. Either way, when they're multiplied together, they're always going to equal 1 times 10 to the negative 14. So here's neutral. More of H3O plus, it's an acid. More of the OH minus, it's a base. No matter what, when these two are multiplied together, it's going to equal 1 times 10 to the negative 14. Make sure you know how to put this into the calculator, because that's actually where a lot of students mess up. It's not that they don't understand the concept, it's that they don't understand how to use their calculator. Whenever you see times 10, you need to push the EXP or the EE button. Some of the more modern TIs might have a third button that you can push, but EXP and EE are the most common. If you're having issues trying to find either one of those buttons, make sure you ask your teacher, because that's how you figure out how to calculate it. So you'd put 5.0 EE or EXP negative 11. 2.0 EE or EXP negative 4. When you multiply those two numbers together, it's going to equal 1 times 10 to the negative 14. So let's do a couple calculations with this. So what is the H3O plus? We're looking for this. So if we look at the equation, H3O plus times OH minus is equal to 1 times 10 to the negative 14. If we know the OH minus is 5.0 times 10 to the negative 8, we can figure out the H3O plus. We're going to divide both sides by that 5.0. Those cancel. So it'll be 1 EE or EXP negative 14 divided by 5 EE or EXP negative 8. You will always put the 1 times 10 to the negative 14th into your calculator first. And that comes out to be H3O plus concentration is equal to 2.0 times 10 to the negative 7. Let's try one last one. Lemon juice has a H3O plus concentration of 2.0 times 10 to the negative 3, so that's going to be our H3O plus. What is the OH minus of this solution? So 2.0 times 10 to the negative 3 times the OH minus concentration, which is what we're looking for, is equal to 1.0 times 10 to the negative 14. Now divide both sides by the 2.0. So the OH minus is then going to equal to 5.0 times 10 to the negative 12. Once again, you're going to put that in the calculator. 1.0 EE or EXP negative 14 divided by 2.0 EE or EXP negative 3. Never, ever, ever type in times 10, negative 13. You will always get it wrong if you do that. And that's how you calculate the concentrations.